Hello, everyone. We are going to talk about earthquakes at transform plate boundaries today. Okay, the last chapter was about convergent boundaries, and this one is about those boundaries that move from side to side. And the most popular one, or the one that we talk about the most, is the western coast of the United States, where the Pacific plate meets up with the North American plate. And those move, the Pacific plate is moving north, and the North American plate is moving south. Okay, so they're moving like this. Along that plate boundary, there is a very popular fault as well that we have talked about before, the San Andreas Fault. And it runs the entire length of the western coast of California. Don't confuse the fault with the boundary, okay? That boundary goes all the way up into Canada and all the way down into Mexico. And the fault line is just a break in the rock that happens along that transform boundary. And it is an area that has a lot of earthquakes. So if you think of like the San Francisco area, if you've ever been to San Francisco, but there is the San Francisco Bay right in the middle of the city. And so there's a lot of bridges that have to connect one shore of that bay to the other. And if you think of this area from an engineering perspective, those people that have to design those bridges have a lot of things to take into account, right? The Golden Gate Bridge is built much differently than any kind of bridge that we have here in the Midwest because it has to be able to move and sway and flex with the 10,000 earthquakes that they have in that area every year. Now, most of those earthquakes are small, too small to even really feel. But occasionally there can be one that is very large. Okay, so why are most of those small? Well, transform boundaries and transform or strike slip faults, transform boundaries have really shallow focuses. All right, we've talked about that before. I'll pick up the top of my Sensi pot here. Okay, so if this is the Earth and the break in the rock happens right here, it doesn't have very far to go to reach the surface of the Earth. And so that wave has a lot of energy. Stop. Hello. Today we are going over chapter 6 in our tectonic iBook, and that is about earthquakes that happen at transform plate boundaries. And we have talked a lot about the transform boundary that is in our country on the west coast between the Pacific plate that is moving north and our North American plate that is moving south, okay? And along that boundary, we have a very popular fault as well that we've discussed, the San Andreas Fault, okay? Earthquakes at transform boundaries have very shallow focuses, okay? So that means that the break in the rock is not very far underground, okay? Remember that deep earthquakes have a focus that can sometimes be like 100 miles down. Transform boundaries have relatively shallow earthquakes, and that is because the boundary is at the surface of the Earth, right? You can actually see that boundary as a scar that goes right across the landscape. And convergent boundaries, they meet up deep, deep, deep underground. Okay, so transform boundaries have shallow earthquakes. If you've ever been to San Francisco, you'll notice that there's a big bay, the San Francisco Bay, right in the middle of the city. And that bay has several bridges that connect it. If you think of this area, or being an engineer, a civil engineer in this area, there's a lot of things to consider when you're making a bridge in an area that has 10,000 earthquakes per year, right? Those bridges are built much differently than the bridges that we have here in the Midwest. So the Golden Gate Bridge, this is a picture of the Golden Gate, it actually sways and flexes with the movement of the Earth. And that is necessary, or they would be rebuilding bridges on a very regular basis. California, again, has the San Andreas Fault, but it's actually considered more of a fault zone. If you look down here at this picture, this is the San Andreas Fault right here that goes right along the coast, but there's all of these other breaks that are significant as well inland from the coast. Can look over here, and if I zoom in on this map, this is a map of all the faults in California. There's a ton of them. And that makes sense because we've got these two plates that are crashing together and they're rubbing against each other and grinding against each other. And that is going to weaken the rock inland from the boundary of those plates, right? Just like if you were to take two glass plates and slam them into each other for millions and millions of years, it's going to crack and be brittle inland as well. And so this whole area of California is prone to a lot of earthquakes, and some really major ones have happened away from the San Andreas Fault. This is the San Andreas Fault that goes all the way along down into Mexico. And even over in this area, oopsie, zoomed in too far. Now I zoomed out. There's a couple ski resorts up in this area by Mono Lake and June Lakes and Mammoth Mountain. Those are very tectonically active as well. They've got some earthquakes there, but they also have volcanoes in this area. And that again is from all of this shifting that happens. All right. So a few that we have talked about, we talked about the 1906 quake in San Francisco. That was a 7.9. And remember that quake, the biggest damage was done after the quake because the gas lines broke and started a fire. And they went to put the fire out. The water lines had also broke. So those are things that they have remedied since then. Those are things that they definitely take into account when they are engineering their city. And they now have structures, water lines, gas lines, things that are different, again, than how they are built here because they have so many earthquakes in that area. Another one, it was in 1989, the Loma Prieta earthquake, which was near Santa Cruz, just south of San Francisco. That was a 7.1 quake. In 1994, there was a 6.7 in Los Angeles. Okay, if we think about, this is a weaker quake, but that is right in Los Angeles, right? So sometimes you'll see more damage or more monetary, it costs more money when there's an even weaker quake, depending upon where it is. If you've got one right in LA, it's going to do a lot of damage. You could have an 8.0 in the middle of the Mojave Desert. It's not going to cost us a lot of money. It might shake up a few lizards, but it's not going to knock over buildings, right? More recently, and it caused a little bit of concern out in California, was in 2019. There was a couple earthquakes that were back to back in that area. And they thought that they were kind of precursors to the big one. We're always waiting for the big one. And they proved to be, significant. They were in the sevens on the Richter scale. But we are still kind of watching and waiting for some of these other faults to have a significant shift in this area. All right. Another transform fault that we haven't talked very much about is one in New Zealand. And that fault actually has more earthquakes than our San Andreas Fault, 20,000 earthquakes per year. Again, same thing. Most of them are really small. But occasionally there's a really big one. There was a really big one the month before that Japan earthquake that we talked about the other day. The Japan earthquake happened in March of 2011, and the one in New Zealand happened in February. Okay, and so there is some link between the two, thinking that that shift in that area of the world triggered, a series of events, and Japan was included in that. Okay, again, so earthquakes that transform boundaries happen. Transform boundaries are less numerous than convergent boundaries. Convergent boundaries definitely have the most earthquakes, but we do see them along these transform boundaries. And again, when you've got two plates that are in constant motion, These plates, the Pacific plate and the North American plate, move on average about 2.5 inches per year. Okay, so that constant grinding creates these big fault zones. So earthquakes along those boundaries can be very widespread. Okay, whereas convergent boundaries are a little bit more localized. All right, at the end of, when you're done watching this video, I am going to post this video about the San Andreas Fault specifically with a little question that goes along with it. And if you've got the time, access the Tectonics iBook and check out this video as well. Okay, that's from UC Davis, a university in California near Davis, which, no surprise, is a really big, has a really big seismology and geology department. There's a lot of people that study earthquakes out at those California universities, and UC Davis being one of the biggest. Alrighty, I'll talk to you soon.